why isn't water considered an
An
element?
element. What is
Okay,
water made
and I believe it was
It got
Delonte.
two. Yes, it got two of them. It's hydrogen and oxygen.
Okay, great. So yeah, so water is not an element because it's made up of two different elements. So it's a compound, right? To be
Yeah.
considered an element, you have to be a pure substance. You can't be made of other things. And water, also known as H2O, right, is made up of two elements, hydrogen and oxygen together. So
So
that's
that's
why
like saying H2O, 2O.
Yes. Yes.
H2O, yeah, H2O is water, right? And so we can show you that. So remember that a water compound is H2O, and I will show you guys what that kind of looks like in an image, just so you have this idea. All right, so this is water. Okay, this is water. It is H2O, right? It is two hydrogen atoms and one oxygen atom. So that's what water is. It's actually a water molecule is made up of two hydrogens and an oxygen. That's how we get water. So it's not an element.
Two what?
Hydrogens. H.
Okay.
H is for hydrogen and O is for oxygen. Right? And when we looked at the periodic table last week, hydrogen is our first element. It's our simplest element. But water is not on the periodic table because water is not an element. It is made up of two different elements, so it is a compound. In order to be an element, you have to be a pure substance. That means you can't contain anything else. And water, while we think of it as a pure substance because we're always drinking it, and we know it to be good for us, it is not what we consider a pure substance because it has more than one element. Okay, so that is water. Water is not a pure substance. All right, let's go back to that share on the PowerPoint slide. Yeah, so water is made up of hydrogen and oxygen, like I said before, okay? All right, so last week we looked at the periodic table and we're gonna kind of continue that discussion of the periodic table. We're gonna make sure we look at all of our atomic math. So we're going to review the math that we need to know in order to take that science test. Yes, you do have to know math for the science test on the GED. Sorry, guys. You thought you were going to get away from it, but we fooled you. There is a little bit of math on there. And we are also going to make sure that we look at what the carbon cycle is. So we're going to be talking today about carbon, right? And carbon is one of our elements, but we're going to be talking about it as it is a compound, meaning it's going to be joined with other elements. We're going to talk about that today as well. So let's go to Schoology. Let's make sure you're in your Schoology class.
Oh, I will Schoology again.
Yes.
And you here you said our discussion post, and you talked about atomic math and a carbon cycle. But when I checked through the discussion, I only saw a carbon cycle, which I actually don't know really about. But I think the atomic mass, it's about what we learned last week.
Yes,
right?
Yes.
About the calculation of.
Yeah, so we're gonna talk about that today again, right? But yes, the atomic math is what we learned last week. And the carbon cycle is what we're gonna discuss today as a new topic, right? So we're gonna review the carbon cycle, and then we're gonna review atomic math and discuss the carbon cycle. But I wanted to start us off with thinking about what the carbon cycle is. So again, I'm gonna share my desktop so you guys can see where you're working. So you should be in your Science 3 course. Make sure you're looking for Science 3 with this green picture and my name, right? That's what you should be looking for.
I went into that.
Okay, great. And now you should be in week 4, the carbon cycle.
How do I get all of this off my screen now?
You need to press escape and then.
Yeah, Mhm.
And then
Yep.
you go to Schoology. You can go to Clever and open up, and then you find Schoology, and then
Oh, that's on my screen. Is Mr. G?
yeah. No, if you press escape, if Mr. G's screen is covered, then you press escape. It will minimize. Then you can go to your. Then you see a little mini.
on my page.
Okay.
You got it, Miriam? Or no?
I came out because you made your screen smaller, so I was able to come out.
Okay, great.
And Mr. G, please, you will forgive me the assignment you asked us to do. I couldn't do it, but I'm going to finish everything this weekend. Please.
Okay, great.
So you said go to
Week 4. The carbon.
The video should come up.
I went into let's see, October.
So science 3,
Friday.
and then we're in week 4, October 2nd.
All right, let me go back. Let me go back, Mr. G.
Okay.
All right. I'm in Clever now, so I go to Google or to Schoology.
Schoology. Yep, Schoology.
Schoology. Lord God, Schoology, go Schoology, Lord.
Yeah,
So
everybody calls
yes.
it something different. Schoology, yeah. Okay. And then you're in your courses, you're looking for Science 3, the green picture with my name. And then we've got to go to week 4 for October 2nd, the carbon cycle.
See that.
It's hectic, but you'll get used to it anyway. Little by little, you
I
just.
see upcoming Friday 2nd.
Yep.
Class for Friday. But I don't see no week 3, 2, okay. Nobody subtract fraction I'm seeing for practice 3.
So you should be.
That's the carbon cycle. That's the one I'm to go into?
Yep, exactly.
Should be a video right there.
All right, so you're in week 4.
Are we watching? Are we going on it?
So the first thing I want you guys to do is look at this discussion post first. All right.
Okay.
So can you describe what's happening in the image? So I want you guys to open up this image that you're going to see. You're going to see this image. And what do you think is happening? And then just put that in your discussion post. What do you think is happening here?
Oh, what else on that?
So that's the image with the person with the mask on?
No, that's the video one. Where's
it's just on it. You'll find it is something, a drawing with a bull.
So you're in week 4. Everybody should be in week 4. Says carbon cycle. If you're not, you're not in the right place.
I'm seeing carbon cycle with Nathaniel Manning and a video. That's on the video, but I don't see the picture that you're saying.
Yeah, I got a carbon cycle picture now. Say handout, but it got fossils and fossil fuels.
All right.
And there are answers and questions down at the bottom.
Let me stop my share for a second. Okay, so let me just double check here. Okay, so in your week 4 folder, you guys should have 5 things. The first thing it should say is, what is the carbon cycle? Do you guys not see that?
Right, got you.
Yeah, that's where you should be. What?
Oh, we're going in that one. Okay, I went down. Okay. Gotcha.
What is the carbon cycle? That's where we're starting. You guys, whenever we're doing my work, always start from the top of the folder, right? So what is the carbon cycle? That's where we're starting.
All right, gotcha.
Okay. So what are you seeing in that cycle? What are you seeing in that image? So I'm going to put the image up.
What you're talking now, Mr. G.
Okay, so I'll put the image up. I'll put the image up for you, so you can look at my screen to see what the image is.
I'm seeing an image now, and it doesn't ask any questions, though.
Right, it doesn't ask any questions. I want you to. The only question I'm asking is, what is it? What do you think is happening? So you can put whatever ideas you think you have. If you're not sure, that's okay too. But just put something about what do you think is happening in this image. Okay, I want you to put like, why are there 3 arrows or 4 arrows? What do the arrows mean? What do the blanks mean? All of that. I just want you to kind of think about it and put it down. It's an image that you guys something that you should be familiar with in general, right? If you just think about it, what is happening? What do you think is happening?
Oh, so there's no chat. We just write it down on a paper that we have or something.
There is a chat, right? So here, I'll share it quick. I'll share it. Sorry, I haven't shared my screen yet. That's my fault. Let me share it. Okay, so right where it says write a comment, that's what I want you guys to do. Just write a comment of what you think is happening.
Oh, write it right there. Okay.
I'll keep the image up, and you just write a comment on this screen here. Just write a comment based on this image. So I'll keep the image up for you so you can see it. So what do you think is happening? What's happening in this image? And just giving me the title of the image is not telling me what's happening. Okay, so tell me what's happening in the image. All right, put it in your comments, and I'm just gonna leave this up right here. And give you guys a couple minutes to think about that. What's happening?
Mr. G, you took yours away.
Did I? It should still be there. Just another minute or so. Just go ahead and write your ideas down. What do you think is happening? All right, so what do we think is happening? What is this image an image of?
It is showing you how things are reproduced and what it does.
Yeah, it looks like a cycle, but
Yeah, he and then he fertilizes it to grow again.
Okay.
So I'm seeing where the sun is giving light to the plant.
Okay.
The plant then sends oxygen to the earth,
Okay.
which animals feed from.
Okay.
The animal, after feeding from it, also send back stuff to the earth, which trees also get from the animals also. Then stuff like boards and all of that will send to the factory. The factory do their reproducting, as in building furniture and stuff like that. But the factory, the thing, because of the factory fuels, it goes in the here.
Okay.
So it's send back things also back to us and animals just the same, trees just the same, which can be damaging to us, to the trees, just about anything that consumes it.
Okay. All right. I love all of that. Okay, good. All right, so what we're looking at here is a very crude and very simple version of what is known as the carbon cycle, okay? And the carbon cycle is how carbon moves through our world, right? Carbon, mostly in the form of carbon dioxide, or what we know as CO2, right? Carbon dioxide, what we breathe out, that's carbon dioxide. So that cycle is what we have in the world here and how it's represented. So carbon is breathed out by animals, right? In this situation, it's breathed out by animals. It is absorbed by plants. The plants convert it into oxygen that is released into the air. The oxygen, right, mixes with whatever is already in the air and all the other fumes and different things, including carbon dioxide, and gets recycled to increase the warming or cooling of the earth, right? And then that carbon is absorbed by different parts of the earth, the soil, animals, ocean, right? Also, when plants and animals die, right, they are made of carbon, and that carbon goes back into the earth as well, right? So there's a cycle where carbon is recycled throughout the world and throughout our earth. And what we're gonna talk about is how carbon moves, right? And why carbon is important. So a lot of people hear about the carbon levels going up and carbon is bad, but without carbon dioxide, we'd have a very cold planet, right? We need it, right? One, to keep us warm, to have that layer of warmth that we have that allows us to be a nice warm planet. And also plants and trees need carbon dioxide, right? They need it. That's what they breathe in and convert to oxygen. So it's mutually beneficial for everybody so that carbon exists. Okay, so we're going to discuss the carbon cycle, and we need to discuss the carbon cycle immediately after looking at the periodic table so that you understand that carbon is an element and oxygen is an element, but when they work together, they become a compound that is carbon dioxide. So we'll look at how to play with that, and you guys will have a whole system, and that's what that video is as well later on in that practice. Okay? All right, but before we get to that today, we have to review what we looked at last week, which is atomic math. I know you guys are so excited about this. I know I am. And we should be excited because atomic math is awesome. And atomic math is what we were looking at last week when we were discussing the different ways that we need to, the different things that we need to keep track of in an atom. So what are the 3 things that we talked about last week that you can find inside an atom? What are the 3 subatomic particles?
Atomic mass.
So those are numbers. I'm talking about what are the 3 things, the 3 subatomic particles.
Yeah.
A P name, an E name, and an N name.
Yeah.
You got the nuclear.
Yeah.
It's not nuclear. What is it? It's almost.
No, it's not nuclear, but
No.
yeah, molecules.
Nope, not exactly. So they begin with a P, an N, and an E. Wait, I heard it. Somebody said it. What
Yeah,
say it again.
And they said
A what?
Protons, neutrons.
Okay, proton. Very good. We got a proton. Okay, we got what else?
Electrons.
Neutrons.
Neutrons. Electrons.
And electron.
And electrons. All right, there they are. Okay, so those are the 3 things that we can find inside of an atom. Okay, in the middle of the atom, what we know as the nucleus, is where we'll find protons and neutrons. And then outside of the atom, we find electrons. Okay, what kind of a charge do protons have? What kind of an electric charge do they have? Who remembers what kind of electric charge protons have?
Electric do they have?
Positive.
A positive charge, right? Good. Positive charge for protons. What about neutrons? What kind of charge do they have?
Negative.
Negative.
Nope.
Okay, neutral.
Neutral.
They're
Neutral.
They're neutral. No charge. No charge. They are neutral. And electrons have what kind of a charge?
Negative.
Negative charge. Okay, so that is essentially what you need to know from last week in order to help you out with this week, right? Because you need to know that protons are positive and electrons are negative, right? And that means they have to have the same number in the atom. If they don't have the same number, then the atom has a charge. We're not looking for that. We're looking for neutral atoms. We don't want reactive atoms. We want neutral atoms. So protons must always equal electrons. Okay, that's the first thing you need to remember. All right. And let me double check. I'll make sure I don't have a summary on the next page. Perfect. Here we go. So a neutron is a small particle found in the nucleus of an element or atom. It does not have a charge. A proton is a small particle found in the nucleus of an element or atom. It has a positive charge. And an electron is an even smaller particle that floats around the electron atom. It has a negative charge, all right? So that's what we need to know. Neutrons are neutral, protons are positive, electrons are negative.
Can you please,
Mr.
can you
G.
please,
Go ahead, go ahead,
Mr. G,
Jennifer.
would you mind? Hey, Mr. G, would you mind just going up just a little bit? I want to copy some of this down if I can take some notes.
Absolutely. So
I'm not-
this,
So you're writing notes, Mr. G, because I'm still seeing the sunlight thing on my screen.
all right, let me stop my share. So you should be seeing what I'm sharing with you. And everybody else was seeing it, right? The PowerPoint slide?
Yes.
yeah, we saw the
The
neutrons
and
and the,
protons.
Right, yeah,
Yes.
that's the slide. Yeah, you saw the slide. Yeah, exactly. So I'm not sure what, so make sure you're looking at the, make sure the Zoom screen is what you're looking at and not your page, Miriam. So make sure you click on the blue camera to pull up my screen. Do you see my screen now? It says a neutron, a proton, there should be bullets.
Okay, I'm seeing it now.
Okay, yes, good. Yeah,
Wasn't
and
seeing
this
that.
also, just so you guys know, it's fine if you're taking notes. I love it if you take notes, but this file is in that folder. These notes are already there, right? So this slide is coming directly from that folder. This isn't anything new or like just for me or anything. This is in your folder. So you have this already as well. So feel free to write it down, but remember that you also have this. You're also in possession of it. Okay, Jennifer, you had a question.
no, it's okay. Thank
Okay.
you.
You said we also got these, is what you said?
Yep, absolutely. Let me show you. So let me exit this. So this is in your folder, Atomic Math. The second file,
I got you. I seen that.
that's what I'm reading from. Yep.
Okay.
I'm not that bad of a teacher, guys. Like I'm not gonna like make you write every single thing down. I'm gonna give you some. They're like, oh man, this man is evil. He just talks his mouth.
It's not
off.
even that.
It's write
It's just
everything
science.
down.
And I know science have a lot of things to do with math.
I know. Okay. So this is where we are, right? So neutrons, protons, and electrons. Okay. Whoop. There we go. What happened? My screen just went blank. Okay, there it goes.
You explained something, like you said, is it the proton that is it the proton or the electron that is inside, the small particle?
Mhm.
What is
Yep.
inside and what is outside?
So what does it say? A neutron is found where?
In the nucleus of
In
an
the
element.
nucleus, right? A
Yeah,
proton is
yeah.
found in the nucleus, and then an electron is
Is an
around.
element. Okay, around. All
Okay?
right.
So neutrons and protons are inside, and electrons
Mhm.
are around. They float
Around.
They're
Okay.
outside.
Okay.
Yes,
Thank
good
you.
question. Okay, so is everybody okay with those three? Protons, neutrons, and electrons? Yes?
Mhm. Yeah.
Okay, let's keep going. All right, so this is the math part, right? So this is how we use that information to read our periodic table, or what we need to read from the periodic table. So in order to find the number of protons in an element, we look for the atomic number. So the atomic number tells you the number of protons in an element. And I'll show you where to find the atomic number just as a reminder. But just so you know, the atomic number tells you the number of protons in an element. All right. The number of electrons are always equal to the number of protons. And I told you why earlier. Why is that? Why does the number of protons have to equal the number of electrons? Who remembers? I just said it.
I think because they need to be balanced or something.
Yes, because they need to be balanced. Positive needs to equal negative. And when positive and negative are equal, they are in balance, right? That's also how we try to exist as people, right? We want to always try to be in balance. Because when we're out of balance and we're more negative than positive, we yell at people, we go crazy, right? And if we're too positive, we don't see the truth of what's happening in front of our faces, right? So
Yeah.
you have to be in balance. You have to be in balance, right? You can't be too much of one or the other. Okay. And to find the number of neutrons, you have to subtract the atomic number from the atomic mass, right? So where do I find these numbers, Mr. G? That's the question you're asking me, right? The atomic number is the number on top in each cell of the periodic table. The number at the top is your atomic number. The number at the bottom is your atomic mass. All right, so let's use this example to find the number of protons, neutrons, and electrons in this carbon atom. Okay.
So do we do it? Are we doing it?
Yeah, we're going to do it together.
Are we solved? Oh, okay.
So what are the, how many
6.0.
protons we have in this element? How many protons do we have? And how do I know?
6.
How many protons do I have?
6.
I have 6 protons, and I know that because my atomic number is 6. And my atomic number tells me how many protons I have. How many electrons do I have?
6.
6.
6. Because the number of electrons always has to equal the number of protons. They have to always be the same. How many neutrons do I have?
You need to 6.06.
So we're not going to really use our
6.
decimal. If we're going to use it, we're going to just round up, just so you know.
Yeah,
You
6.
can't have 0.01 or a decimal of a neutron. So we'll take the 12, right? That's our atomic mass. We take the 12 and we subtract from it our atomic number, which is 6. 12 minus 6 gives me what?
6.
6. So in this element, it's not going to be the same for every element, but in this element, everything is the same. The number of protons, electrons, and neutrons are all 6. Okay? This is the math that we have to do for the periodic table when it comes to science. This is the math that we need to do. Right? We have to figure out the number of protons, electrons, and neutrons. And we're going to do that. We have a couple more examples. We're going to do that a lot today so that people become more comfortable with it. Okay?
No.
So protons, electrons, and whatever
Neutrons.
trons that be is always 6.
No. The number of protons you find out from the atomic number. The atomic number always tells you the number of protons.
Okay, so like if you're looking at a label, like for instance, and use
Yep.
the label as an example, and you see 7 for atomic number, then the protons in it would be 7.
Absolutely, yep. But remember, this label is not going to be here. This label that says atomic number is not going to be there. All you're going to see is what you see on the left. But you have to know how to read what's on the left to interpret it. So on the left, you're only.
Oh, because it's always in this writing.
Yeah, exactly. It's always in that
Okay.
position. Yes.
So just have to
exactly.
know that the top one represent atomic number, and the second one
Perfect.
element symbols,
Yes.
carbon element name,
Mhm.
12.01 atomic mass.
Nice. Yes. Okay. So remember, the atomic number, which is always the number at the top, tells you the number of protons. The number of electrons is always going to be equal to the number of protons, which means the atomic number also tells you the number of electrons. Okay? To find the number of neutrons, you subtract the atomic number from the atomic mass. So 12 minus 6 gives me 6.
So if it
That's
was
why I
7,
have
it would
6
be
sixes.
minus 7.
I'm sorry?
I said if it was 7, it would be 12 minus 7.
Exactly. Perfect.
So what so it's always below the atomic mass.
Yes, the atomic mass is a result of the number of protons plus the number of neutrons.
So I'm saying that the atomic number at the top, it's never over 12.
It's never over the atomic mass, correct? Always.
Okay,
Yes.
that's what I wanted to find out.
Absolutely, yep. All right, let's try another example.
Oh my God, the sitting down is giving me backache.
All right, so Tom, let's try it together. All right. So we have a few examples here. We're no longer dealing with just one. Now we have many. So we have helium, boron, sodium, and chlorine. Okay? The first question says, what is the atomic number for chlorine?
17.
How do I know that?
It's on top.
Very
It's
good.
a top.
It's the top number of the chlorine box, right? So that's how I know 17 is my atomic number. Perfect.
Mm.
What is the atomic mass for boron?
1081.
1081.
Good. How do I know that? It's the bottom number in the
10,
boron box. Okay.
Right.
Okay. How many protons are in an atom of Na?
11.
11.
Where is the NA?
Okay. The Na is here. Na is the symbol for sodium.
Oh, okay.
And I heard people say 11. Why is it 11?
No, what did you say? How many
This is-
protons?
It always equals.
Oh no, it's 11. Yeah. Mhm.
Good. Yeah, I heard it. I heard you guys. You guys are speaking
It
over each other.
always
That's fine.
equals.
Yes, 11, because the atomic number is 11, and the atomic number always tells us the number of protons. Beautiful.
Mm.
Okay. What about
But-
number 4? How many neutrons are in an atom of He?
It would be the same.
Okay, it's 2.
It would be 23 minus 11.
Mm-hmm.
Oh, no, I'm looking at something else. My bad.
Uh-huh.
It would be 2.003, Mr. T.
No, it will be 2. It will be 2. It's still the same. It's the same thing.
Yeah,
Actually.
It'll be 4.
It'll be 2.
Yes, good. It's 2. It's definitely 2.
Yeah.
We always, so one thing you guys should know, always round this number to its the closest whole number, right? So in this case, the closest whole number here would be 4.
It's 4.
Here, the closest whole number would be 11.
11.
The closest whole number here would be
23.
23. And here you would just
35.
35.
okay? All right,
I get it.
because you always want to have whole number responses, okay?
Yeah, I was looking at NA when y'all was talking about the HE.
I got you, all right? So to find the number of neutrons, I have to do 4 minus 2, which gives me 2. That's how I
2.
got 2 for helium, okay? All right, how many electrons are in an atom of Cl?
35 minus 17. The difference.
Nope.
Go again. What's
It's 17.
Yeah.
Protons and electrons.
How many
both gonna be the
electronic?
same
35.
numbers,
35 minus 17. It's 18.
So I think it was it Delonte who was saying that? Go ahead, Delonte, say your answer again, because I don't think they heard.
I said 17.
Why
I
is it
think it's 18.
It's 17 because the protons and electrons are always the same as the atomic number.
Very good. So I asked for the number of electrons, not the number of neutrons. Remember,
It's
the number-
18. It's 18.
no.
17.
So listen, Jennifer, listen. I'm answering your question here.
Okay.
So
Okay.
electrons, right,
Mhm.
are always equal to the number of protons.
Oh,
The number of
okay.
protons is 17.
Oh, yeah. Oh, yeah,
Right.
yeah.
Remember,
Let's again, Mr. G. Electrons are always equal.
to the number of protons. Okay. So how do you find the number of protons? You use the top number, right?
Equals
That
Yeah.
top number doesn't only tell you the number of protons, it tells you the number of electrons as well. Okay, they're always the same because they have to be in balance. The plus has to balance out the minus.
Okay, I was thinking
Oh,
it's the proton and the neutron.
Yeah.
That
But how would you come to 18 though?
I didn't come to 18, it's 17.
No,
She came to
No.
18 because she subtracted 35 minus 17.
okay.
Yes, I was thinking it was the neutron.
Okay, all right.
Neutrons is subtraction.
Subtraction is only for neutrons.
Mm.
All right. Okay, so how many protons and neutrons would be in an atom of chlorine? Now I'm messing you guys up. Making you really
Oh,
17
in
and
chlorine.
18.
Where's the
17 for
chlorine?
the
Oh, it's
proton,
35.
13.
How many neutrons?
35 plus
protons?
17.
no, just
It's
35.
minus.
Remember that your
Oh, it's
atomic
Protons
mass,
are positive.
Oh, yeah.
your
It's
atomic
35.
mass is already equal to the number of protons plus neutrons.
Yeah,
Yeah,
I'm
it's 35.
You just use the bottom number. Round it to the nearest whole number. Just use your
Mhm.
bottom number when it asks you for protons and
Let me wake up.
Mm-hmm.
So you just use the bottom number alone?
yep, because
Mhm.
it's protons and neutrons.
Mm-hmm.
Because it's looking for the
35.
combination, which is your atomic mass. That's how you get your atomic mass. It's your protons and your neutrons together.
Gotcha.
All right, so last question. How many neutrons are there in an atom of Na?
How many
How many
neutrons?
what?
Neutrons. Neutrons in Na.
Oh, okay.
11.
21
12.
minus.
Oh, no.
Very good, Miriam. 23 minus 11 is going to give
Yeah.
you
12.
12.
That's a whole lot to remember, Mr. G.
Not a
We in
whole lot.
notes.
You have to get
23 minus 11.
It is a lot because you got to remember
Put stuff in our
atomic,
notes.
the electronic,
It's 12.
the electrons,
Mhm.
the neutrons. You got to remember the protons and the neutrons. It's a whole lot. The chlorine.
So
Mhm.
what you have to remember actually is just the definitions, right? Of
That's
two
what I'm
things.
saying.
You have to remember the definitions of two things, right? That's really all you have to remember. So let me summarize it for you. If we say I'm going to use a blank page here, I want to summarize this
Oh my God.
because I know that there might be some confusion, but it's actually not as confusing if we can keep track of just these two things. Okay. All right, so we need to keep track of two things. These two things are the definition of atomic number and the definition of atomic mass. If you have those two things, you can.
I know that the top one represent the thing, then the bottom one is usually the bigger number, whatever most time you take away from the bottom.
So your atomic number, which is the top number, right? The top number is the number of neutrons in an element. The number of protons, excuse me, in an element. So this is what you need to have in your mind, right? The atomic number, which is the top number, is the number of protons in an element. If you can remember that, and remember that a proton, because it's P, it's positive, maybe, that might help you as well, right? The number of protons in an element is the atomic number. That's the definition of atomic number, okay? It's a number of protons.
You said that's always be the top number, right?
Always, always,
Okay,
always.
I just wrote that down.
Okay?
Okay.
That
So,
much I had registered in my head, Mr. G.
I'm sorry?
I said that much I had registered in my head
Good,
about
yes,
the
that's good.
atomic and the mass. I know that the mass represent the last number at the bottom.
Good.
And it's usually the bigger number, which you did the atomic minus from.
So the atomic number is the top number. This is the number of protons in an element. I also have to, while I think about that, I have to think about the number of protons. The protons are always what? They are always positive.
Positive.
Right? Because my elements never have a charge, I should also think that, oh, this atomic number not only tells me the number of protons, but it also tells me, the number of electrons, right? Because they should be the exact same. Because I can't have a charge. I have to be in balance. The electrons are negative, the protons are positive, so they should always be the same number. Protons should always equal electrons. Protons equal electrons. Always, always, always. Protons equal electrons. All right. The other thing I have to keep in mind is my atomic mass. The definition of my atomic mass is the bottom number. Okay, so the bottom number, or the atomic mass, is the number, I'm going to use the number sign, the number of protons plus, not do that, plus the number of neutrons. Okay, so protons plus neutrons is the atomic mass. Protons plus neutrons. So if I want to figure out the number of neutrons, right? I know how an addition problem works. Most of us in this room should know how an addition problem works, right? We've done addition before, right? If I tell you that N or A plus B equals C, the only way to find out the number of B's is to
minus it from the C.
There it is, right? So because I know that my bottom number is the number of protons and neutrons, in order to find the number of neutrons, I have to take my atomic mass and subtract my atomic number. Okay, so to find my number of neutrons, I take my atomic mass and I subtract the atomic number. So it is a little bit difficult at first, but I think if you remember these two definitions, it's going to very much help you, right? So even if you need to write this down on an extra piece of paper right now.
I wrote it down, Mr. G, but I'm looking
so that when we can do the math together, you guys will see how that works, okay?
Mm-hmm.
You just have to practice with it. It's going to take a little bit of time, but I promise, of all the things you need to remember in your life, this is one small thing. I promise you, it's not that difficult.
Oh, Lord.
Mr. G, you are covering the downside of what you wrote.
I'm covering it?
Yeah, the downside is covered.
Okay, so we might have to switch how your screen is set up. So if it's covered, grab whatever's covering it and move it out of the way.
Okay,
can't really move, Mr. G, but what is covered is the number of neutrons.
Yeah, it's covered. It's from you because
from you, Mr. G.
Because my screen is occupying the whole laptop already, but you are still covered. Your blackboard.
It's covered, Mr. G. But what happened, because I was following you when you were saying it, I was writing. I actually know what it is you wrote there.
So what is blocking it on your screen?
It's blocking the where you wrote the bottom number is the number of protons plus the number of neutrons.
I got you.
We're not seeing.
What I know, but what is blocking it? What specifically is blocking it?
It's a black
the black screen that says mute, start video, participants, chat, screen.
Perfect.
Share screen.
So what I'm saying to you is try to grab that and move it out of the way.
Okay, that I don't know how
if you move that, you'd have to press leave.
Okay, so
if you press leave, you are leaving the class.
Okay.
Right, that's what I'm saying.
All right, so let me try something here.
So Mr. G need to pull up his screen.
Nope. Share your
Really?
screen with me, Jennifer. Can you share your screen? Wait 1 second.
Okay, how can I share mine with you?
So click the green button that
It says share screen at the bottom, Jennifer.
Oh, okay, okay. I've pressed share. What do
So
I
press
do?
share and then press desk. You have to press the blue button that says share again.
Oh, okay. Where is it? Okay. Oh yeah. Okay. All right.
Okay, perfect. Okay, so when you have your Zoom open, right?
Mhm.
So go ahead and click OK to allow me to remote control.
Okay.
Okay, so when you have your Zoom open, there's going to be different things that are in your way. So if you have something open like the Zoom screen, you have to be able to move certain things out of your way, like the menus and other things. Okay.
Okay.
So for me, for instance, when I share my screen, or what, like there's nothing that, like that whiteboard is the only thing I see. Right?
Okay.
So when if on your end all you see is something blocking it, is because there might be just something in your way that you need to move, and not
Okay.
on my end, because I don't
Okay.
have anything that's blocking it. Right. So let me try
Okay.
something different here. Okay, so let's stop remote control. I'm going to stop your screen share.
Okay.
Okay. So when I pull up my whiteboard, what do you see?
I saw the whiteboard, but I still.
Can you see the whole thing or no?
No, there's still something. Let me see what there's still.
It's still the word at the bottom. It's
Yeah.
neutrons.
So I'm just scared to press things because I don't want to start
Okay.
what do you call this word, to try to do things so that I don't lose
Okay.
the Zoom.
So let me show you all then. I'm going to show you my desktop. Let's see if I can. Okay. So do you guys see the pictures of myself floating in the middle of the screen? Do you see that? What do you see right now? Just the thing that
I'm
says
seeing
time?
good morning, student.
Okay. And you don't see the Zoom controls at all, right?
They are still around.
Okay.
On mine.
Okay, good. So is anything blocking the screen from what you can see?
No,
No,
but
we see everything now.
we're seeing everything, but just the other black side, but we're seeing everything.
Okay.
I think that what they saying is was blocking the screen a little bit is where the names of us the classmates on the side. It's a block.
So that
have
you
our
can
names
grab. So anything that's
I think
blocking,
that's what. Yeah, I
you
think
should
that's
be able to grab it and move it out of the way, because
I see.
Yeah, or you can press hide. Press
or
hide
you can hide
and
it.
hide it.
Okay, there's a place to press hide.
Yeah, try hiding.
Yeah, press that.
I saw an option, view option. Should I press the view option?
So it should be under more, and it should say at the bottom. It should say there's more, and it should say hide meeting controls. Try that.
Oh yeah. Okay. Okay.
Try that.
Yes, I used to see that kind of a thing.
Okay.
Let me see.
And now let's see if that helps.
When you hide it, you can see everything.
Where does it hide?
Okay, that means it just disappeared down to the bottom, so now you have to hover to see it. So can you see the whole whiteboard now?
Nope.
Miriam,
Let
did you
me
hide
see.
your meeting controls?
Huh?
There's a place I used to see hide, but I don't know. Yeah, I can see everything now.
Okay.
Or
So
you press.
Yeah, I forgot. I just don't know what I even pressed. I just stormed on. It just trial and error.
So at the bottom of your screen, Miriam, you're going to have a few options. There should be an option that says more, maybe. And if you go to more, it'll give you an option that says
Now I
hide.
have I pressed something and went into full screen.
Okay. You can escape. You can just click escape to get out of full screen.
And that's it. What I keep saying to you guys, I don't see no escape on my page.
It's not on your page. It's on your keyboard.
Oh, okay.
It's the top left corner. That button. ESC.
Okay.
We have a lot to do.
All right. So
It's
when I press the
funny
escape
and
now,
nice.
what do I do?
Okay, so at the bottom of your screen where the controls are, right?
Mm-hmm.
Go over to the right and you should see a button that says more. Do you see something that says more?
Let me tell you what I see.
Yep,
I
give me the
see
options
mute,
that you have.
start video, participants, chat, share screen, record, reactions, leave.
Okay, so there's no view there. Okay, so what we can try then is at the top you have options.
What I did was still on those things down. I pressed something, but I didn't remember what I pressed. That brought
It's
me.
okay.
That brought me
I'm
to
just trying to
this.
figure out where your options are. At the top, do you have any options, Miriam?
What is that, sir?
Do you have any options at the top of the screen?
No, I'm seeing just the names of those who are in class.
I think would you press chat and see
Yeah,
if
well,
it's going to
you
be
can press on
okay?
top of that.
I think maybe chat. Maybe
So if you-
because I did chat and that something came out.
When I press chat, I say mute. Oh Lord. No, there's no more in chat, just the same.
I pressed chat and then my screen got wider. That was how I saw it. I see. I
Okay.
Mhm. When I press
Just press
chat,
the
that,
chat.
nah.
Just, okay. Oh, mine,
All right,
mine
so
got wider.
there. I already forgot what I was saying to you. So there is no option at the top that says view.
Nope.
In the
Just
top
give
right,
me the names of those that are in the class.
in the top right-hand corner, you don't see view? No? Okay.
And would you take your mouse away down and see if it's going to go up? Because I think when I took my mouse down, all the chat, everything that was written went down. What do you think about that? Take the mouse down. That was when I saw everything.
Okay, so I think what's happening here is you just have your meeting controls are still being viewed, Miriam, and there's supposed to be an option for you to remove that. So I'm not sure because it's coming up for me in a certain place, it's not coming up for you in the same place. So let me see if I can figure out a different way to get you to get there. Okay. All right, yes, that's fine. Okay, let's just return to this. Because I want to make sure. So everybody has these notes, right? On the atomic.
Yes, sir.
Okay.
I'm seeing everything now, Mr. G.
Okay, good.
Okay.
You got it.
Well,
right.
what I did, Mr. G, is come out of it and come back in.
Okay. Yeah, so again, the options, if you're having a hard time doing something, let me know, but it's not on my end. It's usually going to be on your end, okay? All right, let's try back to this thing that we were working on. I already forgot. We were doing our.
I think we were going to the next.
Yeah, we're on to number 7 now. Okay. Sorry, slide, the next slide, which is slide 9. I'm not sure why it's not coming up. Wait.
Let me get out this one. I'm ahead of y'all.
All right, so slide 9 is what I'm trying to get to load for us. And it doesn't want to, that's okay. I have other options. Because I have it on my desktop as well. You guys are not gonna get out of it that easy. All right,
Are we going to another picture?
yeah, so we're on slide number 9. It's not coming up on the screen, so I'm gonna share it in a different way. Oh, there it
It's
goes.
unknown. It's unknown, Mr. G.
There it goes. We want it to be difficult.
It says use the information to provide answers to the question.
So now we have hydrogen. Oh Lord, it went out again. Okay. We have hydrogen, lithium, silicon, and argon. I just can't trust it. So what we're gonna do, we're gonna go back and reshare. We wanna make sure that we get these. We've gotta get this practice in. I'm just pulling up the screen again in a different way. Okay. All right. So here are our slides, are the ones that we're working on right now. So we have hydrogen, lithium, silicon, and argon, right? The chemical symbols for which are H, L, I, S, I, and A, R. Okay. Those are what we're working with. So what is the atomic number for lithium?
3.
For what?
3.
Lithium.
Lithium.
Lithium. Okay, 3.
3. Good. And we know that because 3 is at the top of that box, right?
Right.
We know that that's 3. How many protons does an atom of silicon have? Or Si?
14.
And why do you think it's 14, Miriam?
Because the autonomy is the
Atomic
same
number?
as, yes, is the same as
The number of protons.
Electron.
Good. So the number of protons I find by looking at the top number, which is my atomic number, and it is 14. So that means I must have 14. Okay. What is the atomic mass for argon?
40.
39.40, right? Because you're running in
39.9.
right.
If you guys answered directly, that's okay in this case. But yes, if you round up to 40, that is also acceptable as well. Yes.
Right.
Okay, because if I ask you directly for the atomic mass, if you give me exactly what you see, that's okay. If you round, that's also okay.
Oh, okay.
How many electrons does an atom of hydrogen or H have?
How many what?
One. Okay, 1.
How do you? Why do you say 1, Jennifer?
Because I saw 1 on top.
Okay, good.
And it's
So the top
the same
number
as
is our number of protons and also our
Yeah.
number of electrons. So very good.
Yeah.
Yes, it is 1. How many neutrons are in an atom of Li?
3.
No, not 3.
Really?
It's 7.
Oh yeah,
Minus
4.
3, so it's gonna be 4.
4 because I
Yep.
forgot the
You round it
90.
off.
Yeah, I forgot the 94.
Yeah, so this is 7 minus 3. We're gonna get 4. Okay. Good.
Yeah, I forgot the 97.
All right. How many electrons are in an atom of silicon? Si.
14.
That'd be 14.
That is also 14.
Yeah.
All right. So yes, it's also 14. All right. I lost my pen for a second. I'm not sure why. Okay. So it's 14. What about number 7? How many electrons? So this one we don't know. So we're gonna skip 7. Sorry. We're not doing that. That's too much math. What about number 8? How many protons and neutrons are in an atom of argon?
In argon,
39.95.
40, yeah, 40,
No,
39.
40. Yeah, in this case, 40. We do
Mm.
have to round up in this case to say the 40.
Mhm.
Because I'm not asking you for atomic mass, I'm asking you for the number, and it always should be a whole number for protons and neutrons. Okay, good.
Come again, Mr. G. Could you repeat?
Protons and neutrons. How do you find protons and neutrons? What did I show you on the whiteboard? How do you find protons and neutrons? What's the rule for that?
Protons is always positive, but the neutrons is
What's the note that you just wrote down from me?
No, you need it. You need is the atomic number and the mass together.
Not together. What is it?
I wouldn't have got that one because I'm lost in that one.
What's
What
the
does your
question
note
you
say?
asking again?
What does your note say, Miriam? Read the last note that you just wrote down from me.
Atomic. My last note was that atomic mass bottom number is the number of protons
And
plus the number of neutrons.
okay.
Okay,
So what is the question asking you?
number.
Okay.
So that's why you would end up with the 40.
Ah. Okay, the number of protons and neutrons in an atom is your atomic mass, and that is your bottom number, right? In this case, you need to round it up from 39.95 to 40. All right, and my chat is going off for some reason.
But Mr. G, I said so. You said no.
You said 39.95, right? What did you say?
Yeah, 39.95.
Yeah,
Is it not the same as 40?
It's not the same as 40, right? It's in this case, it needs to be 40. Why?
Okay, when you join them together.
Yes. When I ask you not for atomic mass, but for protons and neutrons, you can use the atomic mass, but always round it because I need a whole number. When we're talking about protons and neutrons, we need only whole numbers. We don't use the decimals.
Okay.
Okay? That's the only difference there.
Okay. It's okay. We'll have to get used to this.
I told you.
Work.
One class per semester.
You have to get it. You have to do it.
Where do you hear Ebony in here today?
Too many classes with too many things to put in this brain.
Yeah, with the whole problems around town.
All right. So you guys have this to work with, okay? You can use your notes anytime to go back over them. They're in that folder, okay, to go over. And if you're watching this recording back because you weren't able to join class today, you guys who are already here in class, you guys are getting full attendance. I'm just saying if you're watching this back and you weren't able to join class today, make sure that you fill out the discussion question. And also you're gonna have to do this practice. So let me show you guys, this is how we're gonna end class today. We're gonna do this practice together. Okay, so this practice number 1 here is on the carbon cycle. All right, so I clicked on it. So you guys have a video that you need to watch. The video is about 4 minutes long, and then you have 4 questions that you need to answer. 5 questions, excuse me. All right, so you're gonna, when you're ready to submit your answers, make sure you put you use the submit button over here and answer the 5 questions, right? They're multiple choice. So make sure you understand if
So you can't answer the question there and submit it. You have to write the answers over the submit.
So when you click submit, you can just put, there's gonna be a blank document that comes up, you can put it in there. Yeah, if you can't write
All
it.
right, so I got one more question.
A, B, or I could write number 1B, number 2, C.
Exactly, I don't need the full word,
Okay.
just 1A, 1A, 2B, 3B, yep, exactly, yes. And then Delonte, you had a question.
That's my question. She took the words right out of my mouth.
Okay, yes, exactly.
I'm sorry, I didn't mean to take it out, I'm sorry.
No, it's okay, that means you guys are,
She stole my sentence. She stole my
Great minds think alike.
yes. Okay, so I'm not gonna make us watch this video together, right? I trust you all independently to go in there and click the video, watch it. Like I said, it's about 4 minutes long. Watch it as many times as you need to answer these 5 questions, okay? And then submit those 5 questions as your answer. And if you want to, another way to learn a little bit more about the carbon cycle is to play this game. So there's a link here, you follow the link, and it opens it up to this game that teaches you how carbon moves throughout the planet, okay? You don't have to log in. if you have, because you don't need to log in, so it'll tell you to log in. You don't have to log in. You can just play the game without logging in. But it teaches you how carbon moves from one part of our environment to another part of the environment. Okay, and it's a really good way to learn about that cycle and how that works. We are going to talk about that cycle more in depth next week, because we're going to talk about both the carbon and the water cycle together, okay, and how they function as systems, all right?
Okay.
So we're going to talk about carbon and water. All right, so I want to make sure that there's enough time and space for questions, if there are questions, and that's pretty much all we're going to do today. I don't want to overstuff your brain with science. But I
But
will.
it's already overstuffed with all of this work from Mr. G.
Yeah, Mr. G, you can't be trying to suffocate us with all this math and science, man. If all is in the same.
Yeah, I know when you're through, I mean, you got to give in Miss Latifah homework by 4 o'clock. Well, Mr. G time isn't bad because he gives you until 7.
7, yeah, that is
bad,
it.
but,
Mhm.
All right, Mr. G, they trying to cut you some slack now, Mr. G.
And just so you know, this handout is in here about the carbon cycle, so it gives you more in depth what the carbon cycle looks like. So we talked about this briefly before, right? But this is how carbon moves through our world. So we have,
in other words, Mr. G, what you put in is what you get.
yes, and carbon doesn't come from nowhere, right? So all the carbon that we have in the world is already in the world, right? We've been using it, and all we do is reuse it, right?
Yeah, I deal with a lot of it in my fish.
Recycling.
I say basically saying all the carbon stays in the world, is what you're saying.
Yes, right? So if it has to come from somewhere, right? And it normally comes from us, but we're right now we are overproducing carbon, right? Because we have all these factories and factory emissions. This produces a lot of carbons, a lot of carbon, and of course we have a lot of people in the world. And what do? People breathe out carbon. Animals breathe
Not
out
anymore,
carbon.
Mr. G.
I'm sorry?
Not anymore.
What do you mean?
With this mask on our face.
Yeah, we can't breathe in. We can't breathe in. We can't breathe in. We can't breathe in nothing but the lint that's on the mask.
I'm done. I'm done.
We can only breathe. We can only breathe in.
This mask is killing us faster than this virus.
Yeah. We can only.
I deal with a lot of
We're not
carbon
able to
cycle
let
inside my
out the
fish.
waste, because what we send out is supposed to be waste and go out in the atmosphere and come back to us with each other way.
Yeah.
But we're actually inhaling what we're supposed to be letting out. It's actually coming back to us. So that's not healthy.
So that is also not true. Okay, so scientifically, that is not true, because we have to remember that in regular professions, as a doctor, as a nurse, or somebody who has to work in surgery, they are on their feet 8 to 12 hours a day wearing a mask in order to do those surgeries properly. And those people have lived long, healthy, and
But guess what?
lives.
Guess what's the difference, Mr. G? Those masks are different from the ones that people are making now.
Well, wait, those masks do not let any impurities out. What we're wearing are cloth masks, which are very porous, but they keep some things in, right? So what we have to remember is that while it may be unhealthy to wear a mask when we are doing very vigorous exercise, when we're asked to wear a mask when we're out and about and in the grocery store for a half hour, or I guess 45 minutes if you're a slow shopper, we are not harming our bodies in the way that people who are standing on their feet 12 hours a day in surgery wearing intense personal protective equipment. So yes, it is not good to wear a mask all the time, but that's why you shouldn't be out and about all the time. So you're behind home.
I stay home, but my husband be, all right, Mr. G, like my husband be out like from 7, and sometimes when he's on call, he doesn't get home until 11.
Yeah.
The only time he has to take that mask off is like when he finished 10 o'clock on his journey to get back home.
Yeah. Yeah. No, I mean, there are some people who are wearing their masks all the time because they're around people all the time. But the idea is...
He does maintenance, so he has to always have it on.
Correct. And so for those people, they're in a very, they're in a different situation from everybody else. But for the majority of the population, we shouldn't be wearing our masks for long periods of time, right? Because the idea is that you should be having distance between yourself and other people. For those people who can't do that, that's why the mask is there. The mask is a last ditch effort. I want to make that also clear too. Your goal should not be to wear a mask. Your goal should be
So
like,
what
oh,
about those persons with asthma, Mr. G?
those people with asthma they are in the same situation. They are in the exact same situation. People who have been told that they should not wear a mask is actually the reverse, right? They should be out and about less than. If they think that they can't wear a mask because they have asthma, then stay home, right? Send
My
somebody
son
else.
has to go to school.
Well, if he has to go to school, then he needs to wear a mask because you have to protect your lungs. If you're not protecting your lungs, you're at more risk. The idea that a mask puts you at risk is not true, right? The mask protects you from what other people might put at risk to you, to your body,
I
right?
understand all of that.
So that's why the mask is there, right? Again, though people who are at risk should be, the first priority should be stay at home. If you can't stay at home, then you wear a mask, right? But the mask is not supposed to be the first option. Your first option should be, do I need to leave my house? Okay,
That's true.
That's
That's
the
true.
first thing. Do I need to leave my
Yeah, I
house?
don't
If I
even go
must leave
outside
my
unless I
house,
have to.
then I will wear a mask, right? 'Cause I
I
I
can't
said, what if people
Out
try
my
to find
house.
ways to leave their house?
out all the time. People, especially in DC, people will try to find a way to leave.
People try to
Well,
find a way just to leave the house to go
but-
get milk. People try to find reasons to leave the house to go get milk. No cereal. I don't
Yep.
care if it's cigarettes, Black and Miles, grease for your hair,
Yeah.
anything.
Yep. Yeah, they leave their house to get one item at a time. Oh, well, you know what? I forgot to let me go back out. let me go get it. No, yeah. So yeah, I get it. I understand that people have a lot of apprehension about the mask, and they should, right? Because the mask it's not healthy in general. But if you stay home, you don't have to worry about a mask. But if you have to work and you have to use a mask, it's not great. It's not great for your body. You are doing harm to your body in that way. But when you are making those hour-long trips out to the grocery store or whatever, you're not doing harm to your body. So don't become confused that I can't wear a mask because it's killing me. All those people that you see going crazy because I want my service. I don't care if I'm not wearing a mask. Those people are insane. Those are crazy people who need to leave the country.
I don't wear my
I
mask.
don't
As a matter of
understand.
fact, I try to have an extra one in all my bags.
Yeah.
So if I should step outside, I say, okay, I already have one in my bag. Let me put this on. Or if like the other day, I went to the store, I totally forgot about my mask.
Yeah.
And I just covered my nose, went in the store and purchased one and put on.
Exactly. Yeah, that's really it. That's all it is. And remember, again, if you're gonna be distant from somebody, you don't need to wear a mask, right? So if you are on the sidewalk and there's nobody around you, you can have your mask down or off or
Yeah,
whatever.
I
right?
tend to do that because that's why I didn't even realize I didn't have the mask on because I went out the house, but I was walking to the store.
Yeah.
But
But-
when I got there, I'm like, oh my God, I don't have on any mask.
But
So
did
I
you
just
guys see
covered
that
my
announcement
nose with my
that
clothes and went in there and
your
purchased one.
president who does not like masks is now he now has
Yes, I wonder what he's gonna say when he look back on what he was saying to Biden the other night. Everywhere you go, you're always having a mask. Now he sees why Biden is always having a mask.
and he is at risk. He's 74 years old.
Listen, we need him to be at risk. God forgive me for the sin.
So remember, guys, especially when it comes to this, right? This is where science comes into play, right? People don't trust science because science is always changing. But if science stayed the same, science would not be representative of the truth, right?
True,
So at
right?
first,
Because things do change.
things change. So
Everything
at first, people
changes.
were saying, oh, a mask isn't necessary. I think a mask is only necessary if you're sick. And then they realized, oh, you know what? Everybody needs a mask. It's okay that change happened. But our president is saying, oh, but at first it didn't say we didn't need a mask. So that's why I don't wear a mask. Things change. When we get more knowledge, we become better at what we do. And then we have to make an adjustment, right?
That's why it says we perish.
When
because
you
of
know
our
better,
knowledge.
you do better. That's a saying that we have in the Caribbean, right? I modified it a little bit, but when you know better, you do better, right? But
Yeah, we
that's-
perish because of lack of knowledge.
right, exactly. And so, but right now, a lot of people are afraid of science because science is always changing. Science has to change, guys. If the science doesn't change, it's not the truth. Like as a child, there are things that you did as a child that you would never do as an adult.
Yes,
you
that's
know
true.
better, right? So that's what happens. So we have to remember that we're living, especially in this time. This is why we need science. This is why I love teaching science as well, because it's about this kind of exchange. It's about asking these questions and finding out the truth, right?
But
Because
Mr.
there are,
G,
yes,
honestly, do you ever think we're going to get out of this mask?
absolutely. I do think there's going to be a time when we get out of this mask, but I also think there's going to be a time when we have to do it again.
Wow.
Right.
So,
Why? For
so,
another thing,
so,
for
so
another
apparently
pandemic.
that's a yes and a no.
Yes.
Are you,
Yes
are you,
and a
are
no.
you
It's a-
saying this for
It's a
another?
yes because I feel like we will get out of this disease, but because of our very global society, right? People are always traveling from points
One country to
unknown
another.
to other points unknown within hours, right? You can be in India at 10 o'clock in the morning, and then at 10 o'clock at night, you're in San Francisco, right? Because that's how our world changes and how people travel, how things travel. Because
Right.
of that, there's no way to isolate diseases anymore. So any disease that one country is
Is this the common
It goes to other countries.
that we,
It's gonna be exposed
is this
to
the
other
carbon
countries.
cycle that we currently talking about now that's going on?
Yeah. So
but
I
but the
mean,
best
everybody
thing is
breathing
for
in
the
and breathing out.
vaccine.
yeah. So we'll get a vaccine. We'll get a vaccine for this disease, and we'll be okay. But
Yeah.
I'm sure that in a couple years, 2 years, 3 years, 5, we're gonna have to deal with this again. There'll be another pandemic. So we have to.
For
They
people
said
that
the
do not want to
vaccine-
take the vaccine, it's for people that do not want to take the vaccine. Like you cannot. I mean, like polio. Today, polio was a very difficult was a pandemic at a point.
Yeah.
But then they had to get. I mean, they got the vaccine. But even in certain countries where they are not being educated about, it still has polio.
Yeah.
So, but like the the West might not, except from the stubborn people, but the West might not get it again.
Yeah. Yeah.
But it's
In
only
this
going to
country,
be like
in this
other
country, we have
countries, like
eradicated polio. Polio does not exist in this country anymore. Like there's
yeah,
no,
but it still happens in some parts
Absolutely.
of Africa.
Yeah.
So that's the problem we're going to
Absolutely.
get.
It's about education, and it's about trust, and it's about people
Mhm.
accepting science as truth, right? And you have to
Yeah.
also accept that truth will change as needed.
Mhm. Mm-hmm.
Yeah.
I mean, science is all about research and observation and, like experience. When you do something and you see that this thing is like this, then you keep, that is how it is.
Huh?
It's just recovery.
Oh, they just talking. I'm more like,
It's a thing about just, is it discovery?
I don't have no more
Yeah.
teeth.
Yeah.
You talking about
Absolutely.
Johnny?
Mm-hmm.
You lying.
Yeah. So
I'm doing it away.
if you guys have
You're
any
lying.
more questions about how this pandemic
Why
is
you gotta
moving,
teach
any
me?
other questions
Cause
about
that's mine.
the cycles and the
I know,
systems that
ma'am.
we're in, let me know. But
No.
yeah, that's all we have for today.
You didn't matter.
I just
That's
I
all
just
that I'm
Yeah,
like,
that's
I just want to know, Mr. G, is week 4 lesson 2 or is it lesson 1?
Week 4 that we're in right now.
Yes. I'm talking about the science. I'm not talking about the math. I'm talking about the science part. Right there where you talking about, right there, what's the carbon cycle?
So this,
That's the question. That's the question you want us to do, yes?
so yeah, that's the question you should have already did it. I think you already did that question, right? What is the carbon cycle? You did that already.
I was doing that. But
Yeah, your
I
response-
do it. I do it.
Yeah, your response is in here, isn't it? Isn't this Delonte's response? Right here?
No, that's not mine. Mine's Deontay Tibbs.
Oh, Deontay. Okay, sorry, I thought Delonte was. Okay, yeah, do that,
I didn't
And
do that, Mr. J.
and then do your practice number 1. And that's it. That's what
Okay.
you got to do for this week.
So, Mr.
Okay,
J, I
all
didn't
right.
do
Thank you,
that
Mr. G.
one.
I'm out.
Okay,
Yeah.
thank you very much and have a great day, everybody. I
You too.
have
Yes,
a great weekend.
Miriam, just
Yeah,
put your
bye-bye.
your comment in here, and then click submit and click post, and then you're good.
So,
right?
what I'm to comment on, Mr. J?
That was the picture that we had at the beginning, right? What is that picture of? What is that cycle? What are you looking at here, right? In this picture, that was what the question was.
I didn't see that picture.
Yes, you did. You sure?
No, I did not, Mr. Jesus. First, I'm seeing this picture. Remember, I wasn't seeing the stuff that I said to you that I'm not seeing anything. I'm still on the other page.
But you responded to the question when I asked you.
Not this, to the other question about the picture that I'm seeing now is a bull with a tree.
Yes.
I didn't see this. I saw the one with the tree.
Oh, you saw this one. I see what you're saying. You saw this picture.
Right, that was a picture that I saw.
Okay. it's essentially the same thing, right? Just one is simpler than the other, right? This is the simple version.
Oh, so I didn't see this one.
Yeah,
Carbon
over here.
dioxide,
Yeah.
oxygen.
So this,
Mr.
the
G.
difference is that I took out the labels out of this one, so just because I wanted you guys to think about what was happening. And then this one has the labels because we want you to see what the actual system looks like. Somebody else had a question, yeah?
I was wondering when we done, so I can go watch the video and do this work.
Yep, okay, yep, absolutely, yeah.
We
So
done?
that's it.
Okay.
So how do so just go back into it, Mr. G, and I'll see the question and then I'll ask.
Yeah,
And
what
so
is it? Yeah, so what is, can you describe what is happening in this image, right? So you already did, so just tell me what your thoughts were. What's happening in the image, that's all. Yeah, it was just a little
I
warm
said
up
the sun is
activity.
giving light to the plant.
Yeah, essentially, right? Yeah.
So
Okay,
I'm gonna
and
write
then
out all of this that I had. I'm like 1, 2, 3, 4, 5, 6 line.
you can write it in.
Okay, let me try and see what I can do.
And then, of course, the practice is just to watch this video, okay?
Okay, so that's just 2. All right, let me try see because I'm having a backache with all of this sitting.
Yes, you have until 7 p.m. to get it in.
Oh, let me do Miss Latifa one first because she's until 4.
Yep. All
Okay,
right, y'all.
thank you. Have a blessed weekend.
You too. I will see you guys on Monday for those who have math and on Friday again for just science.
Okay.